Hi everybody. This is the second part of how to solve a rational inequality. Now if you've never solved a rational inequality or another nonlinear inequality, I'd recommend watching some of the earlier videos I've done on the quadratic inequalities, a polynomial inequality, and another rational inequality that would help you to better understand what we're going to do in this lesson. Alright, so we have this function f of x is x over x minus 1, and I'd like to find all values of x for which this function is less than or equal to 2. So notice that this is the same thing as just solving where x over x minus 1 is less than or equal to 2. Now in the previous lesson I explained why you can't just multiply both sides by x minus 1. That would be the natural thing to do, but it's absolutely wrong, and you'll get the wrong answer every time doing that. And the reason it's wrong is because, remember, if you have an inequality and you multiply by a negative number, you have to reverse the inequality. And so since this is a variable expression, depending upon what x is, it may or may not be negative, right? If x was, for example, 0, I'd be multiplying both sides by negative 1, and I would reverse the inequality. But if x happened to be 2, then 2 minus 1 would be a positive 1, and I wouldn't have to reverse the inequality. So I can't solve this inequality the way that seems most obvious to me. What I need to do is I have to get 0 on one side. So I have to bring the 2 over on the left. So I'm going to write this as x over x minus 1 minus 2 over 1, and that's going to be less than or equal to 0. Now you notice I left some space on each side of these terms because once I get them on one side together, I'm going to have to combine them. I'm going to have to get a common denominator. So I'm going to multiply this by x minus 1 over x minus 1, and then I guess that will give me the common denominator. So notice that this is the same thing as x minus 2 times x minus 1 all over x minus 1. And let's go ahead and simplify that. And what's that give me? X minus 2x plus 2 over x minus 1. And so let's see, I'm going to get a 1x minus 2x, that's a negative x. So let's just write this as 2 minus x over x minus 1 less than or equal to 0. So that's the first step, is I need to get everything on one side and 0 on the other side and combine my terms, getting a common denominator if necessary. And then I can look at this expression and I can see that I have a critical point at x equals 2. I'm going to call that a good guy critical point because that would give me 2 minus 2 is 0, and 0 divided by anything is 0. On the other hand, notice that x equals 1 makes the denominator equal to 0, but I'm going to call that a bad guy critical point because I really don't want x to equal 1 because that would make division by 0. Alright, so these are my critical points. And they are going to divide the number line into 3 intervals. So here's x equals 1, here's x equals 2, and just to remind myself that x equals 1 is a bad guy, I'm going to put an open circle here because I don't want x to equal 1. Now x equals 2, that's okay. In fact, that makes this expression equal to 0. 2 is actually a part of the solution, isn't it? You can see if I plug in 2, I'm going to get 0 over 1 is 0. And 0 is less than or equal to 0. So I want to be sure to include 2 in my solution, but I don't want to include 1 because that would make division by 0. Alright, so these two numbers divide the number line into 3 intervals. I got the interval from minus infinity to 1, another interval from 1 to 2, and another interval from 2 to infinity. And once I have those intervals that are determined by the critical points, I'm going to choose a test point out of each of these intervals. So here I might choose like 0. 0 is to the left of 1. Here I'd probably choose 1.5 or 3/2. And here I might choose 3. Okay, I can't choose the endpoint. I have to choose a value that's actually in these intervals. So now I'm going to see what happens to my expression up here at 0 and 1.5 and 3. So this is the expression that I want to plug that into because I want to see for what values of x this expression is less than or equal to 0. So notice if I plug in 0, I'm going to get 2 minus 0 is 2. Now 2 is something positive. And in the denominator, I'm going to get 0 minus 1. That's something negative. And a positive number divided by a negative number is something negative. In particular, I would get 2 over negative 1 is negative 2. I don't really care that it's exactly negative 2. All I really care about is that it's negative, so I can just deal with the signs. I don't really have to worry about the exact value. Same thing when I plug in 1.5. If I plug in 1.5, I'm going to get something positive in the numerator, and 1.5 minus 1 is also positive, so a positive divided by a positive is something positive. So all I really care about is that it's positive. If I wanted it exactly, what would that be? I'd get a half in the numerator and a half in the denominator. So I think that would just give you exactly 1. All right, but that is positive. If I plug in 3, I would get 2 minus 3 is a negative 1. 3 minus 1 is a 2, so that's negative a half. But again, all I really care about is that when I plug in 3, I get something negative in the top and something positive in the bottom. When you divide those, you get something negative. So I want to know, where is this expression less than or equal to 0? Well, I know it's equal to 0 here at 2, and less than 0 means where it's negative. And so notice it's negative in either of these two intervals. So my solution, where it's less than or equal to 0, is going to be the interval from minus infinity to 1. Now I don't want to include 1 because remember that makes division by 0, union, and I do want to include 2 in this interval, so I put a square bracket, to infinity, and I include 2 because that made it equal to 0. So this is my solution, and I can get that just from the sign chart that I made up here, or by plugging in the test values and seeing where it's positive and negative. Now I can also verify my solution by graphing. If I were to plug into my graphing calculator, let's go up and do my original expression. Let's do this one here, x over x minus 1 minus 2. Okay, so let's graph this part right here. And the reason I'm not going to graph this part instead is just in case I made a mistake when I was getting my common denominator and doing those. All right, so let's graph x divided by x minus 1, and then I want to subtract 2 from that. All right, so I'm going to graph this. This is my standard window. I think I'm going to zoom in on it a little bit more here. Let me graph this on my zoom decimal setting. All right, and basically I want to know, where is that graph less than or equal to 0? Well, you can see it's less than 0 over here. You can see that right here at x equals 1, there's an asymptote, right? You're dividing by 0 there, and that typically is what happens on the graph as you get this big chasm in your graph where there's a division by 0. And so over here you can see the graph is less than 0, and you can also see over here it's less than 0, and you can see it equals 0 right here at x equals 2. All right, so again that corresponds to my solution that I found down here, from minus infinity up to 1, but not including 1 because there's this chasm in the graph right there. The graph is less than 0. And then also it equals 0 right here at 2, and then if you go to the right of 2 out to infinity, it's also going to be below the x-axis, or less than 0. Now I can also check this on my graphing calculator. I have an inequality I can put in here. I wanted to know where this was less than or equal to 0. That would give me, let's see, go under the test menu here. I think I want number 6 there, less than or equal to 0. And then when I graph that, that's going to graph where this expression is true. It's going to graph the number 1 if this is true, and it's going to graph the number 0 if it's false. All right, so notice it graphs true from minus infinity to 1, and then it's not true between 1 and 2, and then it's true again over here to the right of 2. Notice it doesn't tell me about anything about the endpoint here. It doesn't tell me not to exclude the point 1. So you really need your algebra and understand a little bit more what I talked about above in order to get these endpoints correct right there. If I look at these two, the graph and this expression, the inequality here, you can see that it graphed where it was less than 0. So here it's less than 0, so it graphed 1 is true. And then here it's not less than 0, right? It's greater than 0 here, so it left that blank. And then it graphed, actually graphed down here at y equals 0. Then over here it's true, y equals 1, where again it's less than 0. All right? So in terms of this graph right here, I would want to find where this graph is below or on the x-axis, right? Below is less than 0, and on the x-axis is where it equals 0.